In this video, we are going to discuss how to apply equation relating velocity, acceleration and time. So the equation is V final equals V initial plus A into t, where V final here is the final or the end velocity. V initial is the initial or the starting velocity. A stands for acceleration and t is time. So let's take an example. A car starts from rest and goes down a hill with a constant acceleration of 5 meter per second squared. After 5 seconds, the car reaches the bottom of the hill. What is the car's final speed? So here the car starts from rest. So start means this is the initial point. And when an object is at rest, it is not moving. So its velocity here will be equal to 0. And since this is the starting point, this corresponds to initial velocity. It moves down with a constant acceleration of 5 meter per second squared. So this is my acceleration A. After 5 seconds, so this is after time t, car will reach bottom of the hill. We need to find the final speed. Final speed is Vf. So let us first write down all the given quantity. V initial is 0 meter per second. Acceleration is 5 meter per second squared. Time t is 5 seconds. And we need to find what is V final. Now, if you have difficulty understanding what is given in the question, I would recommend first circle all the numbers given and then identify them based on their units. Like meter per second squared is the unit of acceleration. So this 5 meter per second squared will become acceleration A. Seconds is the unit of time. So 5 seconds will become time. Velocity, on the other hand, is measured in meter per second. So if they give you velocity in the question, it will carry a unit of meter per second. And if the question says it starts at rest, velocity at rest is always 0. So now let's apply the equation to find V final. We write V final equals V initial plus A into t. I have everything given here. Let's just substitute. V initial is 0, acceleration is 5, time t is also 5. And when you solve this, you get final speed or final velocity to be equal to 25 meter per second. Next, question 16. A golf ball rolls up a hill towards a miniature golf hole. Assume that the direction towards the hole is positive. If the golf ball starts with a speed of 2 meter per second and slows at a constant rate of 0.50 meter per second squared, what is the velocity of the ball after 2 seconds? So again in part A, the question says ball starts. So start means this is the initial value. So start with a speed of 2 meter per second. So this becomes your initial speed or initial velocity. So I can write my initial speed to be equal to 2.0 meter per second. Question says it slows at a constant rate of 0.5 meter per second squared. Meter per second squared is the unit of acceleration. So this quantity over here is acceleration, but it says it slows down. Now acceleration is taken to be positive if the object is speeding up, and it will be taken as negative if it is slowing down. Since acceleration is a vector quantity, it has direction, and you need to take its value as positive or negative depending on whether it is speeding up or slowing down. So since we are slowing down here, this value of acceleration I will take to be negative 0.50 meter per second squared. Whether you have to take acceleration positive or negative is not given in the question directly on the number. You always have to see whether it is speeding up or slowing down. Time t here is 2 seconds. I need to find the velocity after 2 seconds, so final velocity. So let's apply the same equation again. V final equals V initial plus A into t. V initial is 2 plus acceleration is negative, so I write negative 0.50. time t is also 2. Solve and you get the final velocity to be equal to 1 meter per second. Next in part B, they're asking us golf ball's velocity if the constant acceleration continues for 6 seconds. So we apply the same rule and we take the same given quantity. The only difference is my time t now is 6 seconds. So let's solve for the new time. I use the same equation. V final equals V initial plus A into t. I will keep everything same. Just change the time value to 6 seconds. So V initial is 2 plus acceleration again negative times t, which is 6 now, and that gives me final velocity to be equal to negative 1 meter per second. Now negative sign here means that now the ball has changed its direction and is coming downward. Initially when it was moving towards the hole, we took the direction to be positive. If it goes in the opposite direction, it will become negative. Then we discuss part C of the question. Describe the motion of the golf ball in words with a motion diagram. So the golf ball is initially going up the hill. And when it is going up the hill, its speed is decreasing. It becomes minimum at the top and then it starts to come back down. When it is coming back down, its velocity is negative and it will be increasing. So you have to describe this in words. You can say the ball's velocity simply decreases in the first case. In the second case, the ball slowed to a stop and then began rolling down. If you want to show this with the help of particle model, this represents the case of an object that is slowing down. So in particle model, when an object is slowing down, you draw dots which are coming close to each other. So I draw the first dot, the second dot a bit far from the first, third will be closer to the second. We are slowing down, so the consecutive dots will come closer and closer to each other. This is particle model diagram or motion diagram for an object which is slowing down. Now I can describe motion with the help of velocity vector. Velocity vector is reducing in size as we go up the hill. And then after that, when we try to come back, it starts to increase. Let me also write the time value. We start from 0, 1, 2, 3, 4, and this is 5 and 6. So this is how you can describe the motion of golf ball in words and with a motion diagram. Next is question 17. A bus that is traveling at 30 km per hour speeds up at a constant rate of 3.5 meter per second squared. What velocity does it reach 6.8 seconds later? So this is the initial speed of the bus, V initial, which is 30 km per hour. Now velocity we usually measure in meter per second. So this kilometer per hour I have to convert into meter per second. So how do we do that? I write 30 times 1 kilometer is equal to 1000 meter. If I want to convert this value to meter per second, I need to convert my kilometer to meter, hour to second. So 1 kilometer is 1000 meters. So I will multiply this with 1000 over 1 hour has 3600 seconds. Because each hour has 60 minutes, each minute has 60 seconds. When you multiply them together, you get 3600. So I will divide this by 3600. This gives me my initial speed to be equal to 8.33 meter per second. Then we have the acceleration. Again, rate of change means acceleration. And if you do not understand what this number is, look at the unit. Meter per second squared is the unit of acceleration. So I write A equals 3.5 meter per second squared. Since the object is speeding up, this A will be positive. I want to find what velocity it will reach after this much time. So this is time t, 6.8 seconds. We have to find the final velocity. So we use the same equation. V final equals V initial plus A into t. V initial is 8.33. Acceleration is 3.5 and time t is 6.8. When we solve this, you get final velocity to be equal to 32.13 meter per second. Next question 18. If a car accelerates from rest at a constant 5.5 meter per second squared, how long will it take for the car to reach a velocity of 28 meter per second? So car accelerates from rest. At rest means the velocity here is equal to 0. And this is the starting point of the car. So this will be the initial velocity. So I write V initial to be equal to 0. Now the car accelerates at 5.5 meter per second squared. So this is my acceleration. If you have confusion, just look at the unit. Meter per second squared is for acceleration. So I write acceleration A, 5.5 meter per second squared. How long? That means they are asking you to find time. Whenever the question says how long, you need to find the time t. So time t is missing. Will the car take to reach a velocity of 28 meter per second? So this is my final velocity. This is what I want to reach in the end. So we have V final to be equal to 28 meter per second. So now in this question, we have the final velocity. I need to find the time t. So we apply the same rule. V final equals V initial plus A into t. Now substitute everything that is given to you. V final is 28. V initial is 0. Acceleration is 5.5. I want to find time t. So this becomes 28. You add 0 to anything, it will be the same number. So 5.5 times t. I want to find time t. So we have to divide by 5.5 on both sides. So let's divide by 5.5 on both sides. This gives me 5.09 equals t, or time t equals 5.09 seconds, which you can round off to 5.1 seconds. Next question. A racehorse coming out of the gate accelerates from rest to a velocity of 15 meter per second due west in 1.8 seconds. What is its average acceleration? So here the horse is starting from rest. Again, if you start from rest, initial velocity will be 0. So I write V initial to be equal to 0. And it goes to a velocity of 15 meter per second. To a velocity means this is my final velocity. I'm moving from rest to this value. So this is V final. And V final is due west. Direction west has a negative sign. So I write my V final to be equal to minus 15 meter per second. Velocity is a vector quantity. And whenever they give you direction, you have to put the right sign for it. East is taken as positive and west will be taken as negative. Then the time in which this happens is 1.80 seconds. We need to find average acceleration. Now we can directly apply the rule of average acceleration, which is A equals V final minus V initial over time t. So V final here is negative 15.0. V initial is 0. Time t is 1.8. That gives me acceleration to be equal to negative 8.33 meter per second squared. Or you can also write this as 8.33 meter per second squared towards west. If you're using direction, you don't have to put the negative sign. So if I'm writing west, I don't have to put the minus here. So this is how you can apply equation relating velocity, acceleration and time to solve problems.